This problem is about finding the longest palindromic substring within a given string. A palindrome is simply a string that reads the same in reverse, and we want to output the longest palindrome. And that likely includes itself, as there's no constraint that it has to exclude itself. We know what the kind of base cases are, given that a palindrome has to be a basically symmetrical in its values. And so if the length of the string, we just keep that stored as lengths len s, we know that if len s is less than 2, so if there's only one character, then that means that it's definitely a palindrome. Or we can also check whether the set of whatever characters are in S and the length of that, if that is equal to 1, meaning that across the entire string there is only one unique character, then that means that the entire string itself is also a palindrome. So we can directly return S in that case. Now, the most obvious intuition here is that we want to check for every single combination of characters. So we will be starting from having some starting index and then going up to some ending index to be able to find out whether that range is a palindrome or not. So we will be kind of brute forcing this in a way, and then I will show you a more optimized solution. So we will definitely have a is palindrome checker, and this will be just a returning a boolean. And we can check if a string is a palindrome by checking whether the indices are every single step apart equal. So for we need to know what the length of s here. We don't want to do that. So for I in range length of string to test, if string to test I is equal to string to test, need to know the length of string to test, and we'll set that equal to the length of the string, and then we can just use that instead of recalculating the values, and this will be length of string to test minus I, and then minus a 1 as we need to, it is 0 indexed. So the last thing is the range will be exactly half. As remember that when we're checking the pairs, so for example, if you're testing out whether BAB is a palindrome, length of string to test mod 2 will just be 1. And so we only need to check the values for the 0 index and then the second index. And because it is 1, that is actually 0 indexed, so we need to do an additional subtraction here. But remember, we don't need to test for every single value. We only need to check until we get halfway, and that means we would have checked every single pair. So if the the pairs are not equal, then that means that it is definitely not a palindrome. And if you get through every single pair we check, then we know it is a palindrome. So now that we have this function to kind of know whether or not we have a palindrome, we can define what the max palindrome length we got is, and we will initialize that to 0, but we are supposed to return the actual string. So we need to kind of have a separate global variable to store that. Now we want to actually go into checking every single like combination. So for example, in this input, we will be checking B first, B to B, and then we'll be checking B to A, then checking BAB, then BABA, and then eventually until that. And then we'll be starting from A and then repeating the sequence until we go through every single pair that we can. So for starting char in range length of s, our starting char is going to be equal to, and this should actually be starting index, and our starting char will be s of starting index. And then inside here, we actually need to then know what our ending index is. So for ending index in range, and this range, importantly, will be starting from whatever our starting index is, and we will be going until the length of s. As remember, we don't want to repeat the indices. So for example, if our starting index is a, we don't want to have our ending be less than the starting. We always need to check looking forward until the end of the sequence. So for that, we will get the ending char. And actually, we don't need to know what the starting and ending char is. We just need to know what the substring to test, and that's going to be the string from our starting index all the way up to the ending index plus 1, as remember we are 0 indexed. And then we want to check if this first of all, we need to know what the length of substring to test is, and that is because we don't want to just call is palindrome if we already identified that our the length of the substring is less than what our current maximum palindrome length is. So that will save a bit of calls that might be a bit expensive. So substring to test length to test. So if len substring to test is less than or equal to our max palindrome length, then we don't need to test it, but we can just invert the logic. So if it is strictly greater than, then it is worth checking. So if is palindrome substring to test, then we can update what our value is. So then we update global vars to new max. So our max palindrome length is equal to our length of substring to test, and then our max palindrome string is equal to our substring to test. And so note that what our complexity is here. So we're doing on, and then we have an inner loop, so we are also doing an on again, and then we have an outer loop. So this is actually a cubic time complexity where it's on cubed. And we will optimize this as a next step, but then first we can just finish this version where we return whatever our max palindrome string is. And this should just be length s. And so if you run this, it should pass all of the cases. And this is really the most intuitive solution where we are always checking every single version, but we can do a lot better. So as you can see in our memory use, it is quite optimal. Whereas our runtime is quite slow, as we noted that it is a cubic time complexity. And so we can do a bit better by eliminating one of the actual linear operations that we're doing. So if you go back to the problem, we note that every single time that we are checking this palindrome, it is a linear operation. And we can kind of ask or do the reverse step such that instead of trying to find what the whether or not the substring is a palindrome, we can check within one loop. So instead of trying to have a starting index and an ending index goal that we want to match, we can instead just do a loop once across all of the characters, and we can check how well, what's the biggest palindrome that we can construct at every single index? So for example, what we're currently doing is we have a starting index, and then we have an inner loop that manages the ending index. So we would be starting from A and then B, and then we'd be trying to match every single version. Now, if you can instead just go have a eliminate the concept of a starting and ending index, and instead just look at what current index you're at. So if you're at B, then we want to try to check what's the most biggest palindrome we can create, given that we start at that index B. So at B, we can't really create a bigger palindrome as there's nothing to its left, and there's A to its right. But if you're at A, then we can go left and we can go right. And we know that whatever left value is there, so we can think of the previous character as the left value, and then the next character as the right value, and those match. So if the previous char equals the next char, then this is the biggest palindrome that we can currently form. And then if we try to keep going, then we reach a dead end on the left side. So then previous char is none. Therefore, we return what current max substring palindrome we have, which is BAB. And then we would start at B and then check, and then we would realize ABA is the max, because then the previous char B does not equal the next char D, and therefore it terminates. So this would allow us to kind of eliminate the need of a double for loop, and that would straight away reduce our complexity from n cubed to n squared, which is the almost close to the optimal solution. So we will kind of go and eliminate some of the steps. So we won't need is palindrome. We can just hide that for now. And we will instead be defining a function called something like expand palindrome. And this is just going to take an index of whatever character we're at. So this is just going to be an int, and this is going to return a string. So remember, if you're at like, when we're doing the loop, we will be sending index like 0, and it will just output B in this case, since B is the largest palindrome we can form at that index. And any character at an index is obviously a palindrome in itself, and we're just trying to expand it as much as we can. So we can kind of simplify this a bit. So we don't really have a concept of a substring to test. Instead, we have an index to test, and that is really just our index. So I'm going to do it for index to test in range length of s. We want to call max palindrome at index, and that's going to be a string, and that will be our expand palindrome function. And we're going to just pass in the index to test. And if length, we want to do length of max palindrome at index, and that's just going to be an integer. That's going to be the length of max palindrome to test, or at index, sorry. And if length of max palindrome at index is greater than our current max palindrome length, then we will be updating the values. So if max palindrome length will be equal to the length at index, and then our max palindrome string will just be equal to our max palindrome at the index. And then we can actually just get rid of our inner loop logic. And now all we actually need to do is just implement the expand palindrome function. So this simplifies the complexity to just on squared, which is the ideal version that we would like. So in expand palindrome, here it gets a bit more nuanced, as when we're expanding a palindrome, we need to handle two cases, and the cases depend on whether or not the palindrome that we construct, the largest palindrome, is an odd or even length. Because if the length is odd, for example, let's say we have in this, we're in the second example where the palindrome is of even length. If we only check the outer values, for example, previous char and next char is one index greater or one index less, we will never actually find BB as a palindrome, because if we are checking, for example, the index 1, we will try to check C and B, and those won't be equal, so we will just be returning B. But that's why, like, we need to check another additional case where we try to form the largest even length palindrome, where we would be checking, well, we'll be keeping like the left value or the previous char as the current I, and then we'll be checking if the next char, which is +1i, is a palindrome. And you could do it in reverse as well. It doesn't matter, as long as there's one case that at least tries to deal with the fact that you might end up with an even length palindrome. So we will be doing the first case, well, the most intuitive case first, which is the odd case. Odd length palindrome, and then 2 is the even length palindrome. We want to define what the previous index is, and that's going to be I minus 1. And we want to do what the next index will be, and that's just going to be I plus 1. Now, we want to check if the previous index and the next index are in range, and so previous index has to be greater than or equal to 0, and the next index has to be less than or equal to the length of the string minus 1, as that would be the last index. And if it is, then we can know what the previous char is, and that's just going to be whatever is at s of previous index. And the next char is just going to be what's at the next index. Now, if previous char is equal to next char, then we can basically decrement the previous index by 1, and then increment the next index by 1. And if it's not equal, then we need to break. And even if it's not in range, we need to break. And so we will basically be setting whatever the max odd palindrome that we can form is from the range of the previous and next index that we have gotten up to. So that's going to be a string of starting previous index all the way up to the next index plus 1. And so we will be doing the even length. So in this case, we will just be having a current index, and that'll just be set to I, and then we have the same next index again, and we can set that to +1, and we should rename these values, but I mean it doesn't matter, as we just we will just be resetting it to the current I plus 1. And so in this case, we are checking if current index is greater than or equal to 0 again, and then that the next index is again less than length of s minus 1. And then we can do what the current char is, and that's going to be equal to s of current char, and then the next char is going to be s of next char. Then we can do if current char is equal to next char, then we want to increment the current index by 1, and then we want to also increment what the next char is, or the next index, and that will be 1. And regarding current index, actually, we will be decrementing that, as we want to, for example, in this case, once we match that B and B is well, if B is the current and then B is the next, then that will match, and then we want to check whether or not the previous, so we switch the current to the previous value, and we again continue the next index as the second B, and that way we can still kind of figure out the even palindrome that we can form. So here again, we must break if these conditions don't match, and then the max even palindrome is just going to be the current index all the way to the next index plus 1. And then we must return, well, whichever one is bigger. So it could be the case that if length max odd palindrome is greater than the length of the max even palindrome, then we want to return max odd palindrome, else we just return max even palindrome. I just noticed that the last time that we actually decrement the previous index and the next index, we have gone too far. So our actual solution will be previous index plus 1, and it will just be the next index, as again we are incrementing after we have validated the palindrome. And the same issue is here. It's an while loop, and the same is here. And we can just have that, and it should be current index and next index for the chars. And if you run this, then it should pass all of the cases, and this would be the most optimal solution that you would be probably asked to reproduce. But I do want to note that there is a theoretical most optimal solution that is in linear time, but that goes beyond the scope of this problem. And so for this problem, we were targeting a quadratic O(n) squared time complexity, which we have achieved. And you can see it does do very well in both memory and the runtime performance. And this was achieved by simply breaking, or well, thinking about the palindrome in terms of the forming them at each index versus trying to validate whether or not every single substring could be a palindrome. And that shaves off a complete linear time operation, which is what we wanted. And so we don't need to have this palindrome. And yeah, so that's it for this problem, and thank you for watching.